We need R.
Okay, I'll give you guys some more time to finish stuff later. We're going to go ahead and get started. I think people need a little more guidance before they can kind of get into it more. So today, we're going to kind of review 10.1, we're going to do 10.2, and we're starting with just a little bit on 11.1, the goodness of fit test. On Thursday, in 2 days, you have your homework on 10.1 due. Next Tuesday, you have 10.2 due, and also Project Lab 10, which you have handouts in the back for. The final is going to be 35% on these two chapters, chapters 10 and 11. 12 is now part of chapter 11. So that last class when we covered chapter 10, this class and next class, and maybe just a little bit of the next class after that is going to be 35% of your final. Final is 24% of your grade. So you're looking at roughly a third of a fourth of your grade, a 12th of your entire grade will be on just the things we're covering today, next Thursday, and kind of a little bit like that last class and a little bit the class after that. Right? 8% of your grade. The rest of it is going to be about 20% on the first exam, 20% is going to be based on the second exam, and about 25% final is going to be based upon this exam 3 you just took. Yeah.
So you moved the homework from tonight to tomorrow, or to Thursday?
No.
Or
Oh, yeah.
Okay.
Yeah, so 10.1 should be due on Thursday.
Okay.
If it's not, let me know, and I will move it. But that should be due on Thursday. Okay, good. Also, focus for 3 more weeks. Your final is 2 weeks from Thursday. You've worked really hard all semester long. Do not blow it now. Right? Stay focused. Power through it. Stay on top of things. The final is 26% of your grade. Yeah, so it's 35% and 26%. So really, it's like 8.5% of your total grade is going to be based upon just these couple of chapters that we're covering right now. All right, sorry. Let me continue. Stay on top of your homework, and you're in class quizzes and labs, and your tech labs. This we're going to go through. I think I'm going to do this maybe in a week because it's a weighted mean. So we'll kind of go through this exercise later because it's a big review for the final. So we'll go through that. We won't take time now because we have other things to cover. This other part I'll do later. So let's review chapter 10.1. Everybody has your notes? For 10, chapter 10 notes. It says notes, chapter 10 at the top. Okay, good. Frank, go ahead and read.
Review chapter 10.1. Correlation determines if a linear relationship between variables exists. Regression describes the relationship between variables, that is, positive or negative, linear or non-linear.
Great. Next, Shane, go ahead.
The purpose of this chapter is to answer these questions statistically. 1, are 2 or more variables related? 2, if so, what is the strength of the relationship? 3, what is the type of relationship exists? And 4, what kind of predictions can be made from the relationship?
Exactly, that's what we're trying to figure out. Are two variables related? And if so, is it a linear relationship or some other kind of relationship? Emily, go ahead.
A static has a graph of the ordered pairs of the numbers consisting of the independent variable x and the dependent variable y.
Great. Shane again, go ahead. Shane?
The population correlation coefficient noted by P1 or row 1 is computed by all possible pairs of data values x, y taken from this population. Linear correlation coefficient denoted by R is computed from the sample data and measures the strength and direction of a linear relationship between the two quantitative variables. When explained in this session, it's called the Pearson products moment correlation coefficient.
PPMC. Great. So we're going to be using this PPMC table, which you just got today. The population correlation coefficient is called rho, that weird P. The sample one is called R. So remember, it goes with like the normal letter versus the Greek letter. Greek letter rho, that weird P is called rho. The English version would be just R. And then we're going to compare that to the PPMC table value to get our critical value. Zachary?
Correlation. The range of correlation coefficient is from -1 to +1. If there is a strong positive linear relationship between the variables, the value of R will be close to +1. If there is a strong negative linear relationship between the variables, the value of R will be close to -1.
Exactly. And the nice thing about this, remember 1 and -1, they look like a line. 1 looks like a line, right? So if you're at -1 or +1, then it's like a line. If your R is close to 0 in the middle, that's really kind of like a circle. It's like just a bunch of random dots. It's not a line. So is a line, no line. So and this kind of middle part is always our nose. So why don't you guys take a second with your neighbors and try to figure out, here are the possible numbers up above, figure out which number goes with which of these pictures, and just write them down, 4 numbers across the top and write 3 numbers across the bottom, and just put that out now. Individually, no talking for the first 30 seconds. So that means no talking. You guys are the cameras on, so if everything here is clear. You said. So figure out which number goes with which picture. Write 4 numbers across the top, 3 numbers across the bottom. And chat with your neighbors.
Okay,
15
so
seconds.
see the line ones? The one going upward is 100, the one going down is -100, and then the one that's all scattered, that's 0, and then, I don't know, like, there's so many numbers, I don't know what it is. Maybe you want
like the last one. Is the last one
there's the one on the bottom,
and the top one
and then
yeah.
and then
Remember, I got my stuff last
the
week.
ones right next to those,
So all of them,
I might be completely wrong about that.
the first three were like and then scattered one. Yeah. That's 4, 0, 3, 100. This 2 would be 50.
All right, so we're going to start with this far right one over here. Far right one on the top. You guys see that one? I'm going to randomly pick a name.
That's 3 digits.
Jaden, what is the number of this one out here over here?
0.
0? Okay, great. The next one over, we're going to head left, so this one right here. Then pick a name. Yusuf?
We said 100, positive 100. Since it's
Positive
starting up.
100. Okay, so who agrees with that? Who disagrees with that? Okay. Anybody have a good reason why they might disagree with that? Jeff?
Oh, I would.
So Shane, go ahead.
Because it can only be between -1 and 1.
Right. Correlation coefficient has a maximum of 1 and a minimum of -1. Right, so if we go back to this slide back here, you'll see, right, this is a line. Perfect line, +1. Perfect line with the negative slope is -1. So do you guys want to take just another 15 seconds to chat with your neighbors? Go ahead.
No, the video is it can only be from 1 to 10. But she's saying going up was negative?
Like, what's the sign of 0.5?
Wait, she's saying going up was negative?
Going up is positive.
Yeah.
Like the first thing now?
Oh, because they were just like the numbers shown up there. But it's whatever she's
Alright, you stop, what is it then?
Oh, maybe 1.
One, positive one, great. And how about the next one over to the left, we'll pick a name again. Jennifer. 0.8. Everybody on board?
Yes.
So remember, we can't have these numbers, they don't exist. Because you can't be more than 1 or less than -1. Okay, the last one over there. This very top one, top left up here. Joseph Ramos?
0.6.
Yep, 6. And then we're going to drop down to this bottom one down here. It takes a long time to sort out. Shane. Sorry. Yes, back over here. Over here.
-1.
-1. Next one. Enrique.
-0.8.
-0.8. And the last one right here. Renee.
What are my options?
What was that?
What are my options?
These numbers up here apparently.
Negative 0.5.
-0.5. Good. Everybody all right with that? Okay. If you recall, the sample correlation coefficient, R, is this fairly complicated formula, which we calculated once. My first semester class had to do that all the time. However, you guys can just put your X's into list 1, your Y's into list 2, and then do stat test, Lindreg t-test of L1 and L, L2, and it will give you your R. Give me 3 decimal places on the R. Hypothesis testing. All right, so this is your quiz, right? This is step 1 of your quiz, hypothesis testing. So Dana, why don't you go read for us?
Hypothesis testing. In hypothesis testing, one of the following is true. H naught,
H naught or H1. So here's H naught.
H naught is the null hypothesis means,
Oh, it is.
I don't know what that symbol is.
So
Little
no, not.
specialty.
Rho.
Oh, rho. Rho equals 0. This null hypothesis means that there is no correlation between the x and y variables in the population. H1.
Oh, wait, okay. So null means no, right? In this case, it means no line. Everybody on board with that? No line. Keep going.
H1 is rho equal to 0. This alternative hypothesis means that there is a significant correlation between the variables in the population.
This one means that there is a line. Everybody good with that part?
That should be not equals, but I guess the not part
Oh,
is kind of
you can't
not
see it,
mentioned.
yeah. Did he say equals?
Yeah,
Oh, my bad.
should be not. But
Yeah.
but the, to
Oh,
be fair,
yeah.
the slash through is
Yeah,
not.
the
Yeah,
slash is very, very
I
light.
didn't
You
see
probably
it.
can't see it very well. I'll make it a little bit darker. Is that darker? You guys see it better now?
Yeah.
Okay. Not equal to 0. So it's either equal to 0, which means no line, or H1, not equal to 0, it is a line. Because it's not equal to 0, that means it's either -1 or +1, so it's a line. Guys, remember that? If you're close enough to 1, you're a line. Yes.
So it's always 0? Like,
Yes. Always 0.
Okay.
Because remember that goes back to this picture here. Right? No, here's 0. Can you guys see that? 0. -1, +1. These ones means it's a line. If you're in this range, you're a line. If you're in this range, you're a line. If you're not, then you're not close enough to being a line. Here, are we rejecting H naught over here or not?
Yeah, you reject.
Yeah, so if you reject H naught, it is a line. H naught says no line. So if you don't reject H naught, that means no line. No rejection, no line. Does that, you guys understand what I'm saying? Reject is a line. Okay, so that should kind of get you through steps 1 and step 3. Step 2 is this part here. To find our critical value. Instead of doing it the regular way with the t-table, because it's this is the linear correlation, we're going to use a PPMC table for this one. So it's pretty straightforward. Remember, we have an x and a y. We have 2 variables, so degrees of freedom is n minus 2. So if you have, what is this, 10 pairs here? So my degrees of freedom here would be what? 8. Because it's an x and a y. So we use this 8. So there's 10 things here. So my degrees of freedom, oops, I better change that. Degrees of freedom is equal to 10 minus 2, so it's 8. So I'd be looking along here, and in this case my alpha is 0.01, so I'd grab this one here, right there. That's my critical value. And then we draw the picture a little bit differently. So here we're just going to draw a picture like this, and like that. And remember, it's not equal to, so it can be left-tailed and right-tailed. And it's 0.765, so 0.765, positive and negative.
And zeros in the middle.
Zeros in the middle, exactly. Zeros in the middle, negative ones over here, positive ones over there. So if it's in this range, from 0 to negative 1 to negative 0.765, it's a line. If it's between positive 0.765 and positive 1, then it's also a line. If it's anywhere in between, it's not a line, because remember, like that 0 is just like a big bunch of jumbled up masses, like making just a circle, like a bunch of dots making a circle, right? It's no line at all. Good? All right, so why don't I give you guys another 6 or 7 minutes to finish up part, the first part of the quiz, and then we can go over it if you guys want.